Today we jump into trig verifications. Now, this is probably what most closely resembles a proof in geometry, except we're going to do it algebraically using equations within trigonometry and trying to show that one side equals another. Just like in a two-column proof, you would say, given this, find that. But in this sense, we can actually work on either side that we wish. My basic plan of attack is to look at the most difficult side and try to make it go to the easier side. Or if you can kind of plan ahead at what you're going to try to get, that's always a good idea too. For instance, in this problem, this is obviously the most difficult looking side. I'm probably going to work with this and try to get over to here. And I also noticed that this is a Pythagorean identity, which is equal to sine squared. So that's what I'm going to be working towards. So if I want to get started, let's just say, well, I know here's the Pythagorean identity, 1 plus tan squared is secant squared. So now I have tan squared. We're going to go x over secant squared x. And I know 1 over secant squared is the same as cosine squared. And then tangent is just sine squared x over cosine squared x. The cosines reduce, leaving me with sine squared, which is what I wanted to get to, and I know that sine squared is equivalent to 1 minus cosine squared. And I've now proved that the left side equals the right side. Now you cannot work both sides of the equation. The idea behind a verification is to show that one side equals another, right, and not use the other side to get this side. I did indirectly, but we work on one side of the equation. So in this example, we notice we have a Pythagorean identity over here, which I'm probably going to work towards, and then I'm going to take this portion where we have 4 terms and simplify that. Cosecant squared minus 1, well, 1 plus cotangent squared is cosecant squared, so cosecant squared minus 1 is going to be cotangent squared. So if I can make this cotangent squared, I'm good to go. I notice I have a cosine on top. I'd kind of like to keep that there if possible. And I know 1 over secant is cosine, so 1 over secant, which is cosine, times cosine is cosine squared. And cosecant is 1 over sine, so now I have a sine on the bottom, and sine times sine is sine squared. And that's cotangent squared, which we know is cosecant squared minus 1. It's kind of a push as to what to go for. I'll usually go for the sum and difference side rather than the multiplication side. I think it's sometimes easier just to combine that because there are some common denominators you can find and so on and so forth. So I'll use this, and I think I'm going to go and make everything sines and cosines. Watch what happens. If I say that tangent squared is sine squared x over cosine squared x minus sine squared of x, you'll notice in theory that's over 1, so I can pull a sine squared out, which is what I really want to do because I have a sine multiplied by something here. And then in this case, I'm going to have 1 over cosine squared minus a 1. 1 over cosine squared is secant squared. And we know that secant squared minus 1 is tan squared. And we verified our identity. So in this case, let's just FOIL all this out. We have, actually, let's not. Let's take and simplify this. I have a feeling it may help a little bit. Tan is sine over cosine. And cotangent is cosine over sine. Get an LCD. That's going to go to sine squared x plus cosine squared x over sine x cosine x. Kind of like that. You'll notice that's a 1. So I have 1 over sine x cosine x, and this is sine x plus cosine x. Now notice what I'm going to do. When I distribute this, notice what happens. I have a 1 over cosine, and I have a 1 over sine, which just so happens to be secant plus cosecant. So you'll notice in this problem, I have a choice of a difference of squares here or a common factor here. Doesn't really matter. Let's go with the common factor. So I'll take a cosecant squared out, and then I'm left with 2 minus cosecant squared of x. Now I want to get to cotangent squared, so I know 1 plus cotangent squared is equal to cosecant squared. So I'm going to make a substitution for every cosecant squared that I have. So I have 2 minus 1 plus cotan squared of x. So this is still 1 plus cotangent squared of x. And notice I have 2 minus 1, which is 1, and then minus cotan squared of x. Hey, look at, I got a difference of squares here, which will multiply into 1 minus cotangent to the 4th of x. This cube scares me a little bit. I can give you a little bit of an idea of a way to get rid of that. And the thing that I notice here is I have a 1 plus cosine x, and I have a 1 minus cosine x here. And those are difference of squares, like cosine squared minus 1 or something of that nature. And I know that's a Pythagorean identity. So what I'm going to do here is I'm going to pull apart this sine cubed. I'm going to say that cosine x plus 1 over sine x times sine squared of x. So in doing that, first of all, I notice something that I can say that 1 over sine of x is cosecant of x. Then I can say that that's times cosine x plus 1. Sine squared is 1 minus cosine squared. And hopefully you can see where I'm going now. I can factor. Into a difference of squares. So that's 1 plus cosine of x and 1 minus cosine of x. And any common terms get to reduce, and you'll notice I'm left with what I need. Cosecant of x over 1 minus cosine of x. Finally, here's a little trick that hasn't been brought up yet. Everything in both of these rational expressions here has been factored, simplified, whatever. So I'm really kind of stuck. What we can always do in any kind of verification is to keep the value the same. We can always multiply by 1. That's an identity. And if we see something that will help us get to what we're trying to achieve at the end, that might be the thing to multiply by. Typically, when I see something like this, I think, hey, conjugate. Same first term, opposite of the second term. And if I multiply by the conjugate on the top and bottom, that's 1. It doesn't change any values. And notice what's going to happen. This is, I'm going to leave it as sine times 1 minus cosine. And the reason why I'm doing that is because I need this to stay on the top. The bottom is 1 minus cosine squared of x. Kind of did just the opposite in the last problem. So that's sine of x times 1 minus cosine of x. Pythagorean identity here. Sine squared of x, which reduces to 1 minus cosine of x over sine of x. And that's all we've got. Give it a shot tonight, and we'll talk next time.